In this video, we're going to talk about how to find satisfying assignments to Horn formulas using a greedy approach. So what's a Horn formula? Well, a Horn formula is going to consist of a number of implications, something like x implies y. In fact, we could have one or more things on the left, and we'll kind of see what that looks like. In fact, we could have zero or more things on the left. Basically, if everything on the left is true, then the thing on the right must also be true. And we also have these things called pure negatives, which says that basically one of these statements has to be false. So we might have not x or not y or not z. So just to kind of break down what some of this notation means, let's do an example where W represents my name is Bob, X represents I am a builder, Y represents I can fix it, and Z represents that I am an animated character from Dr. Bowling's childhood. The statement W kind of just means my name is Bob. It's, nothing crazy there. But the statement W with a line above it, we call that the negation of W. And that means that my name isn't Bob. It has to be something else. So let's go through a few examples of implications and negative clauses here. The statement X implies Y means that if I am a builder, then I can fix it. The statement W and X implies Y means that if my name is Bob and I am a builder, then I can fix it. The statement W and X and Y implies Z means that if my name is Bob and I am a builder and I can fix it, that means that I am an animated character from Dr. Bowling's childhood. Here we have an empty clause, which means that I am a builder. It just means X is true. So it doesn't matter what else is out there, X just has to be true. And then we have this example of a pure negative, which means that either I'm not a builder, or I can't fix it, or I'm not an animated character from Dr. Bowling's childhood. And my question is, can I find an assignment of true and false to each of the variables W, X, Y, and Z such that all the clauses above are satisfied? And we're going to use a greedy approach to do this. Remember that when we have a greedy approach, that basically means I'm going to take the easiest or most obvious step at each point. The book is going to call the approach we'll use here a stingy approach, because we're basically only going to assign the value true if we really, really have to. What do I mean by that? We'll start by noticing that if everything is false, then clearly all my pure negatives are good. So start by setting everything false. While there is an implication where everything to the left is true, set the thing on the right to true. So basically, we'll just keep on going through the implications. Those are these X imply Y type statements. And as long as there is something that is implied by something else that's already been set to true, then we make that new thing also true. Once we're done with doing that, and maybe, we delete the implication from our list after that so that we don't keep looking at it over again. Okay, so we do all that, and then after, check if all of my negative clauses are satisfied. If so, I have a solution. If not, there isn't a solution. And that gives us a nice approach. One thing we might ask is, why is this true? Well, clearly, the if so, I have a solution. If we get to the end of this process, well, let's think what we've done. We've gone through all of the implications, and all the implications where everything on the left is true, we've already set the thing on the right to true and deleted it. So we've obviously satisfied all of the implications, because any implications that are left, there's something on the left that isn't true. So we've taken care of all the implications, and we've also taken care of, well, if all the negative clauses are satisfied, then we've taken care of those too. If we haven't, well, notice that we only assigned a value to true if it had to be true. So we start, like in a moment, we will start by assigning x to be true, because in any assignment, x has to be true. And then we'll go ahead and see if x has to be true, what else has to be true. And we keep only assigning true if every single possible satisfying assignment assigns that true. And that's kind of the invariant that makes this work. So I'll star that and say we only assign true if every satisfying assignment assigns true. So that means that if I get to the end and I've assigned a whole bunch of things true in a way that one of my pure negative clauses isn't satisfied, then that means that there's no way I can possibly satisfy this Horn formula, because everything in that clause has to be true, which means that it's impossible to satisfy that pure negative clause. So let's go ahead and do our example here using this greedy approach. I'm going to start by assigning w, x, y, and z to false. And then let's go ahead and run through the Horn formulas. So first, I'm going to see if there's any implications with nothing on the left-hand side, because if there are, then that thing has to be true. So, hey, I notice here, for this statement, I have an empty implication saying that x has to be true. So let's go ahead and make x true right now. Okay. Now let's see, is there anything on here where if x is true, then the thing on the right has to be true? Well, I see that in this clause over here, which I'll circle in blue, x implies y, which means that now, since x is true, y also has to be true. And we've seen that in any satisfying assignment, x has to be true, which means that in any satisfying assignment, x is true, and therefore y is also true. Now let's look at everything else. This clause says w and x implies y, but guess what? W isn't true, so I don't need to worry about that. Similarly, this says w and x and y implies z, which would mean that, well, again, I don't need to worry about that because w is still not true. So we've gone through all of the Horn clause, or we've gone through all the implications, and there's no implications left where everything on the left is true. So now I'm going to look at the pure negatives, and I'm going to say, is x false, or is y false, or is z false? That's basically what this is asking. We're asking, am I either not a am I either not a builder, or I can't fix it, or I'm not an animated character? We see that I am a builder, I can fix it, but I'm not an animated character. So we've satisfied, and I'll circle this maybe in purple or maybe yellow. We've done this one because z is still assigned false. So this is a nice satisfying assignment of that Horn formula. Just for the sake of example, let's do another one where maybe I add in a new formula, which I will draw in purple here. And that will just be another implication that we'll just say my name is Bob. And then everything will go amiss. So we'll see what happens here. So before we go ahead and do that, let's note this gave us a satisfying assignment. And if you look at false, true, true, false, that satisfies everything here. Because x is true, which implies y is true. W is false, so I don't care about this statement. W is false, so I don't care about this statement. X is true, which needs to be the case, and in this case, Z is not true. So we've satisfied everything. Now I'm going to put something in that breaks everything. So let's restart. Now let's go ahead and look at this again. So we once again have X has to be true, because that statement there is true. And while we're at it, let's go ahead and note that W has to be true. So I'll just circle that in purple because it's already purple. So that means this statement here is also going to be true. Here we have that X implies Y. So we'll once again be setting, since X is already set to true, that means I need to set Y to true here. So we'll go ahead and change Y to true. Here we have W and X implies Y. Well, guess what? We already set Y to true, so great, it's nice to see this, but it doesn't do anything new. But then here I have that W and X and Y implies Z. If my name is Bob and I'm a builder and I can fix it, then I am an animated character from Dr. Bowling's childhood, which means that we now need to circle, due to this clause, I need to set Z to true as well. And notice now we've set everything to true, which means that I'm going to have no hope of satisfying this pure negative clause, which would mean that in this case, once we've added that purple statement, there's going to be no solution. So we noticed that just adding one statement turned this from something that had a satisfying assignment to something that didn't. And we also saw that we have this nice greedy approach that allows us to kind of simply go through a Horn formula and determine whether it has a solution. In fact, you can implement this in linear time. I would need to look up how to do so. But I encourage you to think about it if you have some spare brain cells, or maybe look into that a little bit. I'm not going to go into it here, but what I will say is that we have this nice greedy approach towards satisfying this certain type of Boolean logic type statement. So there you go. There's a little bit about Horn formulas.